Equations of the first order but not of the first degree. Please check the previous video where we find out solutions for equations solvable for p, for y and for x. This is a continued video where we check out Clairaut's form. So what is the Clairaut's equation? A differential equation of the form y equals to px plus f of p, where p equals to dy by dx. We name this as equation 1. This is called Clairaut's equation. Now its complete primitive is y equals to cx plus f of c. How do we get this? We get this by replacing p by c in the given equation. Now first we are going to see the justification, then we will look for an example. Okay. So first we will need to differentiate the given equation with respect to x. Then p equals to p plus x plus f dash p dp dx. This gives us either dp by dx equals to 0, which we name as equation number 2, or x plus f dash p gives us 0, which we name as equation number 3. Now when we solve equation 2, that relation gives us p equals to constant, let's say c. This we name as equation 4. Now from the first equation and the fourth equation, we eliminate p and obtain the complete primitive in the form y equals to cx plus f of c. Now geometrically, this represents a family of straight lines. Now from equation 1 and equation 3, we obtain x equals to minus f dash p and y equals to minus p into f dash p plus f of p. This we name as equation 5. Okay, so now we see at once that it contains no arbitrary constant and therefore this is not a general solution. But this is obviously a solution of the given equation. So in fact, the solution we get now, this is the singular solution of the given equation, which means of the equation number 1. Now we'll solve an example. So let's take a look at this one. X square into y minus px equals to p square y. Here we put x square equals to u, y square equals to v, so that 2x dx gives us du and 2y dy gives us dv. Therefore, p equals to dy by dx equals to 1 by 2y dv by 1 by 2x du, which means x by y dv by du. Now substituting this value we get of p in the given differential equation, we get x square into y minus x square by y dv by du equals to x square by y square dv by du whole square into y. Or this implies y square minus x square dv by du equals to dv by du whole square. This gives us v equals to u dv by du plus dv by du whole square, which is in fact in Clairaut's form. Now the solutions are, the complete primitive which we get is v equals to cu plus c square from this one, or this can be written as y square equals to cx square plus c square. Also, the singular solution of this one is u square plus 4v equals to 0, or x to the power 4 plus 4y square equals to 0. So in this way we get the solution of any given equation. Now we have come to the extended form of Clairaut's equation. So let's take a look at this one. Extended form of Clairaut's equation. For this, we need to solve y equals to x into f of p plus phi of p. Now differentiating this with respect to x, we obtain p equals to f of p plus x into f dash p plus phi dash p into dp by dx, or dx by dp plus x into f dash p by f of p minus p, it equals to phi dash p by p minus f of p, which is linear in x. Now suppose that the integral is capital X of x, p and c equals to 0. The result of eliminating p between this equation and the original equation is the complete primitive. Now let's take a look at an example of this one. Okay, now a very important example, this one. Solve and find the singular solution of the differential equation. What is that? It is sine x dy by dx cos y equals to cos x dy by dx sin y plus dy by dx. Okay, so the solution. First we need to put dy by dx equals to p. So the given equation reduces to the form sin px cos y minus cos px sin y equals to p, or sin px minus y equals to p, or y equals to px minus sin inverse p. This is in the Clairaut's equation. This is the Clairaut's form. Now differentiating this with respect to x. We get p equals to p plus x dp by dx minus 1 by root over 1 minus p square dp by dx, or dp by dx within brackets x minus 1 by root over 1 minus p square equals to 0. From here, dp by dx equals to 0 gives us p equals to c. So the general solution will be y equals to cx minus sin inverse c. However, when we take a look at this one, which is x minus 1 by root over 1 minus p square equals to 0, this gives us p square equals to x square minus 1 by x square. So from y equals to px minus sin inverse p, we have y equals to root over x square minus 1 minus sin inverse root over x square minus 1 by x. Now this is the singular solution. So in this way the equations are solved.